I would suggest that you pause the video and try this warm-up. Hopefully this is what you got when you were looking at the dimensions. So just remember the tick marks. The first bracket is dealing with the x values. We go from the smallest x value to the biggest x value. And then the third value is what the tick marks are increasing or decreasing by. And then the second set of brackets are the y values. All right, so today we're moving on to section 1.6, which is all about other types of equations. So today we are going to be specifically looking at polynomial equations by factoring and looking at how to solve radical equations. So a polynomial equation is the result of setting two polynomials equal to each other. Here are the steps that we're going to do while solving these types of equations. We first want to move terms into general form. So remember, general form, get everything to one side, make it equal 0. Then we'll factor. And then once everything's factored, because it equals 0, we'll set each factor equal to 0 and continue solving for x. So let's look at this example. It says solve by factoring 4x to the fourth equals 12x squared. So notice that we have one monomial equal another monomial. So I'm going to move that smaller degree over to the larger degree. So I'm going to move the 12x squared over by subtracting. So then that way we can get everything to one side. So these are not like terms. So we've got 4x to the fourth minus 12x squared. And now this equals 0. Okay, and now we can start factoring. Remember, the first step when factoring is look for GCF. Well, notice between 4 and 12, they have a 4 in common. Between an x to the fourth and x squared, you take the smaller exponent, so they have an x squared in common. So if I divide each term by that, that's going to give us an x squared minus 3 left over in parentheses. Now, because 3 is not a perfect square, even though x squared minus a number, if that number is not a perfect square, we are not going to be able to factor it any further. So because my GCF contains a variable, and obviously I have a variable inside parentheses, I'm going to set each of those terms with an x equal to 0 so I can continue to solve for x. Now, when we were talking about quadratics, remember, because our equation was an x squared term, we had two answers. Well, now notice that my degree is really a 4 because that's the biggest exponent. So that means that we should have 4 solutions here. So I'm going to start solving for the x squared in this first equation by dividing by 4. So x squared equals, well, 0 divided by 4 is 0. Now that I have x squared by itself, I'm going to take the square root. And so remember, when you take the square root in an equation, you have two solutions. However, because the square root of 0 is 0, and there's no such thing as a positive 0 and a negative 0, I only have to write it once, but realize that I do technically have 2 zeros as my answer. So there's two solutions right there. And then if I look at the other equation, I can isolate that x squared by itself by adding the 3. And then now that x squared equals 3, just like the last equation, I can take the square root of both sides. Once again, I have two solutions when I take the square root. Square root of 3 is not going to be able to be broken down any further. And so while it only shows me having 3 solutions written down, I do in fact have 4 because, like I said, remember, I technically have 2 zeros. So I have 4 solutions. If we look at the next one, solve by factoring, once again, this time I have a binomial equals a binomial. I got to get everything to one side so it can be in general form. Because the bigger exponents are on the left, I'm going to once again move everything over to the left. So I'm going to subtract the 8x. I'm also going to subtract the 12. Now, none of those are like terms, so that gives me 2x to the third plus 3x squared minus 8x minus 12, and now that equals 0. And so now we can start factoring. This time, because I have 4 terms, remember, we're going to factor by grouping. So that means I group the first 2 terms together. I want an addition sign breaking up my terms. So I'm going to keep the negative with the 8. So now I'm going to start taking out GCFs from each of those sets of parentheses. So in the first set of parentheses, they only have a variable in common. They have an x squared in common. So that leaves us with a 2x plus 3. Going to bring down that addition sign. So what does negative 8 and negative 12 have in common? Well, they definitely have a negative sign. The biggest number that they have in common would be a 4. And then what's left over? Well, that would be a positive 2x, and then a negative divided by a negative makes that a positive 3. And so the nice thing about this is because I have the same thing left over in parentheses, that means I can continue factoring because both of those terms have this 2x plus 3 in common. That's my GCF that I'm going to factor out. And notice that leaves me with an x squared minus 4 left over in parentheses. This still equals 0. Now, technically, x squared minus 4, that's still factorable because we do have a perfect square. So we have a difference of squares, which means that, well, what multiplies to negative 4, but technically then adds to 0, and that would be a positive 2 and a negative 2. So I have everything factored. Notice that my degree is 3 because that's the biggest exponent here. So that's why I should have 3 different answers. Well, I've got 3 different factors that I'm going to be able to set equal to 0. And now I can start solving. So I'm going to subtract the 3. And I'm going to divide by 2. And so one of my solutions is negative 3/2. I'm going to subtract the 2. So another answer would be negative 2. And then here I'm going to add 2. So my last and final solution would be positive 2. So while x squared minus 4 is factorable, if you didn't factor it, you should still get the same answers because you would have had to then just add the 4 to the other side, take the square root, and when you take the square root of 4, you have 2 solutions there. All right. Let's take a look at this one. So we're going to solve by factoring. Once again, I'm going to get everything to one side to get it into general form. So I'm going to move the term of negative 64x over so I can then have my bigger exponent stay positive. All right. Now that it equals 0, I can start factoring out. In this case, we have a GCF of x. So that leaves us with an x to the third minus 64 and left over in parentheses. Now, x cubed minus 64, this is something called a difference of 2 cubes. So we've talked about differences of squares. There's actually 2 different definitions here. So let's say I have a cubed minus b cubed. There is a specific formula that's going to help us factor this. So what it would be a minus b times the quantity of a squared plus 2ab plus b squared. All right, if I had a sum of 2 cubes, I'm sorry, it's not 2ab, I think it's just ab. All right, so then over here we would have a plus b times a squared minus ab plus b squared. All right, so here are 2 different formulas if we have 2 different cube terms being either added or subtracted. So notice that in this case, if I have x cubed minus 64, notice that 64 is technically a perfect cubed. That would be 4 cubed, okay? Because 4 times 4 times 4 is going to get a 64. Okay, so technically then, if I have x being cubed minus 4 being cubed, if I follow that definition, x is going to represent a, 4 is going to represent b. I can start substituting those terms into that particular formula. So we would keep that GCF on the outside. So the x from the outside there is going to stay there. Now I'm going to follow the top definition here. So a minus b. Well, like I said, technically that's your a term of x and 4 would be your b term. So we're going to have x minus 4. Then that's going to be multiplied by a squared. Well, if a is x, x squared is x squared. Plus, then I want a times b. So x times 4 would be 4x. Plus, then I want b squared. So 4 is b. 4 squared would be 16. All right, so notice that this trinomial of x squared plus 4x plus 16 is not going to be factorable because I cannot find numbers that multiply to a positive 16 but only add up to a positive 4. So I get to set each factor that contains a variable equal to 0. All right, obviously I don't have to do any work in order to solve for x in the first one, so here's one of my solutions. I'm going to add the 4 over to get another value of x, which turns out to be positive 4. Okay, remember, we should have 4 solutions because of my exponent here. And so because we determined that x squared plus 4x plus 16 is not factorable, then remember, this is a quadratic equation. If it's not factorable, notice how there's an x term, so we can't do the square root method. So it's between either us doing the quadratic formula or completing the square. So we can really do either one of those. Let's complete the square. If I was to complete the square, I got to move that 16 over to the other side. So I'm going to have x squared, plus 4x. This now equals negative 16. So I take the term that's in front of the x, I take that, I divide by 2, and I square it. Well, 4 divided by 2 is 2, and 2 squared is going to get me 4. So we're going to have x squared plus 4x plus 4 equals negative 16 plus 4, because remember, we have to add that term to both sides. The whole point is that that trinomial now is factorable. It factors into x plus 2 quantity squared. Negative 16 plus 4 is going to give me negative 12. Now, because I have this squared term isolated by itself, I can take the square root of both sides. That gives me x plus 2. Because I took the square root, that gives me 2 solutions, both a positive and a negative. Because there's a negative number under the square root, I know that I'm going to have an imaginary number. Notice 12 is not a perfect square, but it is 4 times 3, and 4 is a perfect square. Square root of 4 means that 2 moves to the outside with the I, and the 3 will stay underneath the radical. I'll subtract the 2 over, and so then my other 2 solutions would be negative 2 plus or minus 2I root 3. So there are my 4 solutions, because 2 of them right here, 4 and 0. All right, so I would suggest that you pause the video and solve by factoring. Okay, notice that this time I got everything moved over to the right-hand side. So I subtracted the x, I subtracted the 1. It's in general form. I was able to then factor by grouping, and then I was able to get my 3 solutions because remember, it was degree 3, so there are 3 answers. All right, now let's move on to radical equations. A radical equation is an equation in which the variable occurs in a square root, cubed root, or a higher root. It is crucial that the solutions are checked back into the original equation because not all values will work. Case in point, anytime you have an even index, we don't want negative numbers underneath it because then we would get imaginary numbers. So here are steps for solving radical equations. If necessary, we're going to arrange the terms so that one radical is isolated by itself on one side. We will then raise both sides of the equation to the nth power. So if it's a square root, we raise it to the second power because the index and that exponent are going to cancel each other out. If it was a degree 3, so if my index was a cubed root, then I would raise it to the third power, and so on and so forth. We'll then solve the resulting equation. If the equation still contains radicals, we'll continue repeating by then getting another radical isolated by itself, raising both sides to whatever that nth root is, and so on and so forth. And then we'll make sure, like I said, we always check our solutions. So let's solve this equation and check our solutions. In this equation, notice that I have a square root and it is isolated by itself, meaning that all the numbers that are with the square root are under the square root. Had there been a number outside of the square root, we would have to then either add or subtract it over or possibly multiply or divide it over. But since all the numbers that deal with the radical are underneath it, we have that radical isolated. So because it is an index of 2, because it is a square root, that means that I am going to square both sides. Because whatever the index is what I raise both sides to. And so when I square square root, that gives us just what was underneath that radical, and then x squared is x squared. Okay, I'm going to start moving everything to one side. And so because x squared is positive, I'm going to move everything over to the right. So I'm going to add the 8x. I'm going to subtract the 20. So now I have 0 equals x squared plus 8x minus 20. And so we have another quadratic equation. Because I'm dealing with an x term, we can't do the square root method. But if we can find numbers that multiply to negative 20 but add to 8, well, then we can factor. And we actually can in this case. I can find two numbers that multiply to negative 20 but add to positive 8. That would be a positive 10 and a negative 2. So then I can set each of those equal to 0 to finish solving for x. So that would mean I have to subtract the 10. I'd have to add the 2. And so my two possible solutions would be x being equal to negative 10 and positive 2. But I'm not circling those answers until I've checked to make sure that they work. So I'm going to first check x equals negative 10. So I go back to my original equation. Underneath the square root, we'll have 20 minus 8 times negative 10. On the other side, I want to know, does that really equal? Well, in this case, I'm plugging in negative 10. So when I have two negatives multiplied together, that really becomes positive. And 20 and 80 turn into 100. When we take the square root of 100, we get 10, and notice that 10 does not equal negative 10. So actually, negative 10 is not a solution. I cannot circle that. So that's why it's important that we're checking our answer. So now let's check when x equals 2. So underneath the radical, we'll have 20 minus 8 times 2. And I want to know, does that really then equal 2? Well, 8 times 2 is 16, so we'll have 20 minus 16. 20 minus 16 would be 4. And the square root of 4 is, in fact, 2. So that one does check out. So negative 10 does not work. And my only answer in this case is x equals 2. Sometimes they might both work. Sometimes they might not work at all. So if neither one of those works, then we would say it's the empty set or no solution. Okay, taking a look at another one. Once again, notice that my square roots is isolated by itself. There's no numbers outside of it on the same side. So right away, I can go ahead and I can square. So I'm going to square both sides. And once again, when I square root, that just leaves me with what was underneath it. But this right-hand side is where you have to be careful. Do not just distribute that square. Remember, if I'm squaring something, I'm multiplying it by itself 2 times. So let's make sure that we multiply and distribute this out correctly. X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is another negative 1x. And a negative 1 times a negative 1 is a positive 1. So then we've got some like terms on the right-hand side. This gives us then x squared minus 2x plus 1. I want to start combining more like terms, so I'm going to keep the x squared positive by moving everything over to the right. That would give me then 0 equals x squared. Negative 2x minus 6x is negative 8x. Notice that 1 minus 1 is 0. So now that I have it in general form, I can start, and in this case, I can factor. I can take out that x that they have in common. That would leave me with x minus 8. Set each of those equal to 0. And so notice that my two possible solutions would be x equals 0 and x equals positive 8. But I can't just circle them. I have to check. So let's check when x equals 0 first. So going back to the original equation, underneath the square root, we'll have 6 times 0 plus 1. And I want to know, does that really equal then 0 minus 1? Well, anything times 0 is 0. So we're dealing with the square root of 1 equals 0 minus 1 is negative 1. And notice that 1 does not equal negative 1. So that one does not check out. So 0 cannot be my answer. If I was to check then x equaling 8 underneath the square root, we'll have 6 times 8 plus 1. On the other side, we'll have 8 minus 1. Well, 6 times 8 is 48. Add 1 more. That gives us 49 under the square roots. 8 minus 1 is 7. Notice how the square root of 49 is 7. 7 does equal 7. That one checks out. So once again, one of my answers worked. One of them did not. Technically, both of them could have worked or both could not have worked. So it's important to make sure that you are checking all solutions. All right, so go ahead and see if you can try this one. All right, so notice this first one is a tiny bit different because that -6 was not underneath the square root. So you had to add it over to the other side first. Then it was just like that last example that I did. I squared both sides. I made sure that I very, very carefully multiplied out that x plus 6 quantity squared, moved everything over, was able to factor, checked, and once again, only one of the solutions worked. All right, so that is us solving by factoring as well as solving radical equations.